In this video, we're actually going to begin working with differential equations and talking about finding solutions. All right, so when you very first started learning about equations a long time ago, you had multiple things being equal and you wanted to see, okay, what makes an equation true? It's whenever you plug stuff in and the equal sign actually makes sense. So your teacher might have said, like, plug in 1, 1 and see if that makes sense. And you would do it and you get 3 and 3, and you know 1, 1 was actually a solution. So you did this before you actually learned how to solve equations. You just want to see kind of what it means to be a solution. If I plug it into the equation, it makes the statement true. And we do the same thing with differential equations. So we're not going to learn how to actually solve them quite yet, but we want to make sure we know what a solution actually looks like. So for now, we're going to be kind of given an expression and you figure out if it's a solution to the differential equation. So this is good practice for taking derivatives. So the first thing, if I have y equals x squared, I want to plug y prime into my equation. So the first thing I need to figure out is what is y prime? Well, y prime is the derivative. I do the power rule and I get 2x. So now I can plug y prime in and 2x equals 2x. And that's true. So this is a solution to the differential equation. And this is obviously a very simple example, but this is the basic idea of you plug in your derivatives and anything else you know and see if the equation is actually true. And so here's one that's already a little bit more complicated. So they give us our y, and we have this differential equation. So the things we can plug in is we can plug in our original y here, and then we have to find y prime to plug in there. All right, so let's find y prime first. We have to remember how to take derivatives. So the e to the negative 3x part, when you take the derivative in exponential, you get the same thing, but then you have to multiply by the derivative of the inside, in this case that exponent, you're getting an extra negative 3, all right, plus 2. All right, so that is my y prime. So now I can take that and plug it into my expression. So y prime is going to go first. All right, plus 3 times y. So I'm plugging all this y, so this 3 is going to be multiplied by all of this. Right. What I'm going to do is just simplify the left-hand side and hope that it equals the right-hand side. So again, multiply that 3 through everything. And you'll see that you have negative 3 and 3 of the same thing, so those cancel. Combining like terms, I get 6x plus 11. So the left-hand side is 6x plus 11, the right-hand side is 6x plus 11, so that is right. That is a solution to the differential equation. This is kind of an AP style question, so it'll give you this equation and say which of the following are solutions to the differential equation. So I basically have to just check multiple things, but for each one, if you look at our original equation, there's y double prime, it's the second derivative and the first derivative. So I gotta do the second derivative and first derivative for both of them. So first, y prime for this one, take the derivative of sine is cosine, and I have to multiply by 4. And the second derivative, I have to do the same thing. Derivative of cosine is negative sine, and I have to multiply by 4. 8 times 4 is 32. Then I have to do the same thing for the next one. Y prime is going to be 6 e to the 2x. Y double prime is 12 e to the 2x. I had to multiply by that 2 each time because of the chain rule. And the bottom one, c is just some constant, so it's the same thing. I have to multiply by 4, so 4c e to the 4x. Multiply by 4 again is 16c e to the 4x. All right, so again, just practice with taking your derivatives, making sure you remember the chain rule, especially when you're working with those exponentials. All right, but now for all of those, let's try to see if they satisfy that equation. So the first one, negative 32 sine of 4x minus 6 times 8 cosine of 4x plus 8 times 2 sine of 4x. And right away I can tell this is not, if I combine all this up, it's not going to be 0 because I have some sines that are not going to cancel, and then I have some cosines mixed in as well. The chances of all that stuff canceling is 0, so this is definitely not equal to 0, so 1 is not a solution. Now let's check it out with our second equation, 12 e to the 2x minus 6 times 6 e to the 2x plus 8 times 3 e to the 2x. And there's a bunch of e to the 2x's, so we're going to have 12 minus 36 of them plus 24 of them. And those, the positives and the negatives cancel, so this does equal 0. So this one is a solution. And lastly, try the last one. 16c e to the 4x minus 6 times 4c e to the 4x plus 8 times c e to the 4x. And just plugging in all my stuff. I got 16 at the first part minus 24 second part plus 8 in the third part. And 16 plus 8 is 24, so those are going to cancel out, and this gives me 0. So both of these last two are correct. All right, so that's a kind of AP style question where they give you multiple things you have to check, but the situation's still the same. And another AP style question is they kind of leave in an extra variable for you to figure out. So they tell you your y, and they say, for what value of k will that be a solution? So let's just try to do the solution with the k in there. All right, we're going to take the derivative first. It's just like we saw in the last one, derivative k is just a constant, so that's just going to stay. But e to the negative 2x, we have to multiply that extra negative 2. And then the next part, the 4 cosine of 3x part, derivative cosine is negative sine. Then I have to multiply that extra 3 on the inside. So that's our first derivative. Second derivative, same thing. Then multiply by another negative 2 when we do the derivative of e to the negative 2x. So we positive 4. And the derivative sine is cosine. I have to multiply by another 3. All right, so now we know our first and second derivative. We can plug those into our expression. So the second derivative goes first. All right, plus 9 times the original equation. I distribute that 9 in. Uh, 9 times 4 is 36. All right, and we'll see that the cosine parts are going to cancel. We can combine like terms to see this is 13k e to the negative 2x. All right, and we want that to be equal to the right-hand side. So right now I've just been looking on the left-hand side, but we want that to be equal to the right-hand side. And we see if we cancel out the e to the negative 2x's on both sides, 13k has to equal 26, so k is 2. So our final answer is k is 2. That would make it actually make the equation make sense. All right, so here's one for you to try on your own. All right, you're given dy dx, and you want to figure out or verify that's a solution. Oh, sorry, this is your differential equation. All right, and you want to verify that that y is a solution to that differential equation. All right, so go ahead and pause the video, try it on your own, see if you understand these solutions. All right, and you should get that this is true, other than the one typo that I had. This x should be a t, because it doesn't make sense to have two different variables, but you'll see that the derivative is equal to that. So if I plug this into the left-hand side, you get those two things are exactly equal. All right, so verifying solutions is mainly just practice with taking your derivatives and then plugging them into your equation to make sure the equal sign makes sense.